Hello, hello, hello. Good morning, good afternoon, wherever you are. Welcome to Kubernetes and Enterprise Guide, third edition. Well, we don't actually have a name for this thing, Scott, do we? It's live streams, chapter streams. We need
Yeah,
a peppy
gotta
name,
gotta come up with
marketing
some
name.
name. Yeah,
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 something that really captures the depth of what we're doing. But anyway, I also realize this is a really important chapter for multiple reasons. One, it gives all the folks who didn't go to KubeCon something to do,
Hmm.
right? Because I don't want to be you
Uh,
wouldn't want to be a yeah. Anyway,
no, I
sore
want to be
subject.
there.
But this will also be the halfway point, right? 18
Yeah.
chapters, or no? Next week's is this week 8 or 9? How
This
many chapters do we have?
is
18 or 19?
19.
So I only minored in mathematics, to be fair. So it's a little unfair to hold me accountable for this. But
I just asked ChatGPT.
yeah, that's a good point.
I
Although
just said, how many chapters? I'm just kidding.
yeah. Whew. Um, the crazy thing is we'll ask ChatGPT what's 8 plus 8. It's going to tell us 37. But anyway, so my name is Mark Borstein, CTO at Tremolo Security, and my co-author, Scott
And
Sorovich.
Scott Sorovich, and from a tier 1 global bank dealing with cloud Kubernetes.
So this was one of our first new chapters in the book, or at least the first new chapter that I wrote. And we're going to be talking about secrets. Can you keep a secret, Scott?
No guarantees.
No guarantees.
I'll
And
try.
that's sort of the thing, right? Like that's kind of the right theme for this chapter because, we talk about secrets and everybody talks about secrets in Kubernetes. And almost everybody gets it wrong, I think. Like people just don't, from the are secrets encrypted? Should they be encrypted? What is the difference between, say, a secret that is, what are the point of Kubernetes secrets? Like they're just configs, right? And they're encrypted using base 64, right? Waiting for the lightning bolt to
I think
hit
it's
me.
that code word, right? It's encoded,
Yeah.
not encrypted. And there's a big difference between the two of those.
So what are your thoughts here, Scott?
In one way, how it's misunderstood or how it's.
Yeah, I mean, you've got you've got a little bit of a I don't want to say unique, but you're used to dealing with secrets in large enterprise.
Mhm.
And what kind of pain do they cause you?
Yeah, I mean, rotation, right? Any kind of place you're at, you can't leave. You should never have left long running anything, right? But we did in the old days, right? I mean, I've had the luxury of being in IT for so long. At one time, you didn't have DR data centers even. Remember when everything just kind of ran in one, you just kind of said, oh, okay, we'll fix it on the fly. Same idea then secrets coming out or use a service account in Windows, for an example, to run my, a SQL server. Yeah, you probably don't want to leave that password forever. Common back in the day. So rotating those can be a pain, right? You need some kind of automation for these. In the Kubernetes world, it's interesting. And I know we've had many talks like this ourselves, Mark. And, people say, cool, I won't do a Kubernetes secret. So it's secure. I'm going to use Vault, right? And I know we'll talk about this even more we do runtime. I've had people in certain organizations where they sign off on security saying that makes it secure. I'll accept I can exec into the container and I can get that secret, right? It's just not in kube control get secrets anymore. Then of course you got deleting a secret that, hey, might have had a cipher in it or a generator, and then how do you get that back? Or can you get that back? And then you have other add-ons like external secrets operator. So there's a lot of discussion on it. There's a lot of more complexities that I think people really think about.
Yeah, and I think one of the first misnomers when it comes to Kubernetes secrets is, is the point of a secret to keep things secret? Like I don't think that's true, right? Like I don't think the point of a Kubernetes secret is to maintain a secret, right? Like what, and we kind of start this in the book. The interesting thing about the first half of this chapter is, excuse me, the first half is all uh theory about what is a secret. What do you do with secrets? What's the difference between different types of secrets and configuration data? And one of the things that I think also kind of plays into this is this idea that um, you want to externalize all the information that's inside of your cluster, right? Like etcd is a great place to store transactional data, but it's a horrible place to store configuration data. Right, because if something happens, the bad thing happens, you're not going into etcd and decoding it into YAML, right? Like that's not gonna happen. And so as a cluster operator, we're always talking about and always striving for how do we externalize all of our configuration? And that's where GitOps comes from, right? Well, we all like Git. Well, like might be a strong word, but we use Git, right? And so we want to externalize that. Can we put our secrets into Git? And the answer is like, no, don't do that. No, I don't care if you're encrypting it, right? And we'll talk about that in a second. So, if you're not willing to put it into a Git repo, just go with that for a second. Where do you put it, and why do you put it there? And that's, I think, really where this chapter spends the most time. By the way, and I was just about to say, if you're out there watching the live stream, but of course, Jack.
Hey, Jack.
Saying hi from the Windy City. Hello, Jack. Thanks for
Hey.
coming on and saying hi. If you are watching us live, please feel free to ask questions. If you are not watching us live, ask questions. We'll get back to you on the YouTube channel. And we do have our first question. I thought it was an access token to a resource, not so much a focus on secrecy. So I think this is actually, thanks for asking the question. I don't want to mess up that name. Booyakasha. I hope I'm getting your name correct. If I'm not, I do apologize. But it asks a really great question. So I think along those lines, and I kind of mentioned this originally, secrets are not about secrecy. Secrets are not about keeping the secret. I think secrets are going to boil down to a couple of things. One, you store a secret, and anybody who's interviewing for a Kubernetes job, this is the first thing you gotcha question a lot of people will ask, and you should know, why are secrets stored base 64 encoded when config maps are not? And the answer is because secrets often have binary data, and you want to preserve that binary data. It's base 64 encoded only to have that binary data. It has nothing to do with keeping it secret, right? Having a separate object type allowed the Kubernetes developers to give you different types of RBAC rules. So you can say, I'm going to allow access to config maps, but not secrets, which is still a little silly because if you can create a pod, you can get to the secret. But no, secrets are not about secrecy. Secrets are mainly about management. And we're going to be talking about Vault today and using Vault as the example in the labs. But Kelsey Hightower gave a demo to the Kubernetes SIG Auth team several years ago. And he did a demo of Vault with Kubernetes. This was probably when Vault was doing its first integration with Kubernetes. And, he said something at the time that I hadn't thought of before, but really made sense. He said, secrets management is not about keeping the secret. You're going to lose the secret. It's not if, it's when. The question is, how quickly can you track who had access to that secret? And how quickly can you replace it? And that's ultimately what you get out of Vault and any other secrets manager. Whether you're talking about Vault, whether you're talking about the secret systems you get from the various clouds, any of these secret management systems, you're not getting a way to keep the secret secret. You're keeping a way to keep these secrets easily rotatable. And so that is really what we're going to focus on is how do you quickly update those secrets? How do you rotate them? And even before we get into that, as I'm going through here, let's first talk a little bit about what a secret looks like, right? So I'm actually just going to share up the book.
I think we're going to show that, Mark. This might help because I want to go back on that question a bit about the access token, right? Because there are different types of secrets, and some could be used for access, right? You got the secret you get for your service account potentially, or of course your Docker pull secret, right?
Yep.
But they can also have TLS data in it. So I think in that question, yes, they can be used as an access token. We've kind of covered this with authentication a bit as well. But yeah, I think showing these will be beneficial.
Yeah, so we got so here's an example secret. If you had chapter 6 running, or actually, I don't think we ran OpenUSA in chapter 7. Oh yeah, we did. We did end up. It doesn't matter. Here's the secret that you'll see from OpenUnison as an example. I probably just had this handy, and you'll see that it's just got data, and that data is base64 encoded, right? But it's just a Kubernetes object. Now, one of the things that we dive into when we start talking about secrets and how it's created, or actually one of the things I want to point out about a secret is, in addition to all of the typical stuff you see inside of a config map, because it looks a lot like config map, with the difference being that the data is base64 encoded, and it's got this type thing. So at one point, there was this idea in Kubernetes that you had different types of secrets for different types of validation. So example, you could have a TLS secret, and TLS secret had to have certain keys, and those keys had to have certain things. You have a Docker secret, it has to be formatted. This was before CRDs existed, so it was a little difficult to make various changes to the API. Vast majority of your secrets, especially with config data, are going to be opaque. So in an example here, we try to create a secret of type TLS. Yep, here it is, type TLS, and that fails, right? Because it's not actually a TLS secret. So once we get through that, then we start talking about how we deal with secrets in the book. And I'm not going to walk through the pages, but one of the things that, if I can figure out where my cursor is, there we go. One of the things that the first thing we start talking about in the book is when we start talking about secrets, we start with threat modeling, right? Because that's really what you have to think about is, where's the threat going to come from? I once had a coworker who said, I should be the security guy because I'm just paranoid. I don't trust anybody. And that's not correct. Like you talk to really smart security people, they're like, well, no, you can't protect against everything. You have to threat model. You have to figure out where's the bad thing most likely to come from. And when you sit down and you look at a Kubernetes cluster, where's the bad thing going to come from? Is it going to come from your web app having a security flaw in it? Is it going to come from somebody accessing the cluster with the cluster API incorrectly? Is it going to come from somebody stealing your backup tapes, right? Like where is the threat going to come from? And then we get into, secrets at rest. Like, do these secrets need to be encrypted? And I will say that I'm a little bit of a contrarian here. I don't think encrypting secrets at rest in etcd is really that important. I don't think it buys you much of anything. It sounds good. It makes for a nice checkbox. Like sometimes compliance says you got to do it, and compliance trumps security every single time. But especially on-prem clusters, I don't see the value of it.
I tend to agree with that one. Okay, it comes up a lot, right? It's a checkbox. It really is. And I mean, the chances are if it got compromised in your cluster, they have the TLS secrets anyways to get in there.
Right.
I mean, so yeah, you might walk out with that CD, but if you got that file, you probably got the certs anyways. I mean, you can
Well,
still get into a lot
yeah,
of
that's the
information.
thing.
So
Well, and like I remember, so I don't know if you remember, I want to say this was probably maybe 2021, maybe it was sooner. I don't know. Time is a blur, but there was a rash of S3 bucket attacks, right? Amazon S3 bucket attacks where people were accidentally leaving their or may accidentally or maybe not, but they're uploading data to open S3 buckets that had no authentication required. So security through obscurity. As long as you knew the URL for what you wanted, you could just go grab it. And in order to combat this, Amazon immediately said, we're encrypting everything. So if I have API access and the API is able to decrypt it, what does it matter? Now, to Amazon's credit, you also have to have authorization to the API key. So in that instance, it might have helped. But for the most part, encrypting at rest does very little to actually protect the data from what's going to be most of your threat model. Now, if you've got a real specific threat model that says encryption is going to help you, then awesome. But it's something to think about. Now, if your vendor does it for you, awesome. Like if it's just a checkbox and it just works and they take responsibility for it, great. Hey, Kafka's here. Bonjour, my friend. But we're getting a regular crew on this live show.
We are.
But so if your vendor does it for you, awesome, go for it. But if they don't, I wouldn't go nuts trying to do it.
Or understand what it provides, right? Because it's really meant for somebody going in and ripping drives out and taking them home. Like, okay, yeah, it's encrypted now. But like you said, people are genuinely surprised, and I'm like, well, it's encrypted, but I'm logged onto the Linux server. Well, guess what? The OS is decrypting it. It has to, because it has to be able to see that data. So they get surprised sometimes, and I'm like, that's just not what it means, right?
Yeah, exactly. And so, now the question is, all right, do we, once we say we, secrets are at rest, we've talked a little bit about Vault, which is an external secrets manager. We talked about how do we externalize secret data. And one of the things that I found, it was a blog post in April 2022 by a gentleman named Mac Chaffee, called Plain Kubernetes Secrets Are Fine. And the link's in the chapter. And the hypothesis of this blog post is, look, there is a there seems to be this goal in the Kubernetes world that once you've decided I'm going to externalize my secrets into something like a Vault or any other secrets manager, I'm not going to allow those secrets into my API server, right? Because that way they're stored in etcd. If I lose that etcd, I'm going to have problems. The issue, though, is that the only common API that exists for accessing secrets is the Kubernetes Secrets API. So if you are trying to write something that is to a standard, right? Like that's all you got. You can either say, I'm going to access them directly inside of my pod, or I'm going to pull them from the secret API. And so like that's it. And the secret management vendors are in no rush to help come up with a common API language. I brought up the idea on SIGAuth once, hey, could we make the secrets API proxyable? Right? Like set up a way that if somebody hits the secrets API, it would proxy off to to a secrets manager, and I just kind of got some chuckles. And I'm like, no, we will never do that for a lot of good reasons, right? Because you don't want to be in a situation where the API server won't work because it can't reach the external, the external secrets manager. So, plain Kubernetes secrets are fine, right? Like you want to externalize them from a management perspective, but from a security perspective, and Mac Chaffee does a great job of walking through the threats. You don't actually have fewer threats because you've externalized the secrets. You have better management of those secrets. He also kind of gets into, and this is a little out of scope, but like he gets into in specific with Vault, and we'll see this when we go ahead and launch Vault. When you launch Vault, Vault has this kind of fun way that it will not run. You have to unlock it. You have to unseal the secrets, which if you think about it from a Kubernetes perspective, how do you automate that, right? Like you put a key somewhere that's accessible it's a pain in the butt. And so what ends up happening is folks end up saying, we'll just run it unlocked, because it turns out that storing your secrets locally inside that database unencrypted is just not going to cause a lot of problems. And so, so we get into that. And then we do talk a little bit about GitOps and sealed secrets and why this is a terrible idea. So the concept of a sealed secret, and we talked a little bit about this before with Git, right? You want to keep your configuration outside of the API server. You have this idea called a sealed secret, and sealed secrets allow you to encrypt a secret and put it into Git. So if you lose your Git repo or somebody gets access to it, they have this encrypted mess. Can't do anything with it. Problem solved, right? Well, if we go back to where we started this conversation, we started with rotation and tracking. Git is specifically designed to never, ever, Git is specifically designed to make it easy to lose track of, right? You accidentally push a repo to the wrong origin, and now it's sitting on public GitHub or public GitLab. And that's why a lot of places, even that use GitHub internally, you can't get to GitHub public from inside your network. They shut it down. Some of that is to keep you from getting malware, but some of that is to keep you from pushing malware, pushing things by accident. And so you don't want to use sealed secrets. The other reason is you can't, so you can't follow it in case you lose it. But then think about the scenario where one secret doesn't get lost. All the secrets get lost. Now you have to generate a new set of keys, decrypt everything, change all the secrets, re-encrypt it, recheck everything. That is a pain in the butt. Like, I mean, I guess you could ask ChatGPT to do it for you, but that's going to be a running gag. So, the problem that you're going to run into is that sealed secrets don't actually get you where you need to go. So, don't bother with them. Like if it's okay to store in Git, then it's not really super important to begin with. I want to revisit here because I think I missed where's my mouse? There we go. Is it because the data in Kubernetes cluster is mainly in transit and ideally hardened through RBAC? So I think this is in reference to, do you need to encrypt at rest? I think you're hitting on the right idea here, because the security of the data is far more about access management. So RBAC is part of it. policy management, which we'll talk about in a couple of weeks. Authentication, security, making sure that the tokens that are used are short-lived, so that somebody can't jack a token and start using it against your API server. So yeah, that is a big part in reference to why security or encrypting at rest. It's good, but it's not the end game. So I've been talking a lot, Scott. Do you have any thoughts?
No. I was agreeing with everything you were saying on that. Mark, and it's a conversation we get a lot. Is again, encrypting at rest, which you're going to do. Honestly, if you're going to a backend array, it's encrypted at rest anyway. So someone's going to steal the data. There are reasons to do it. There are reasons not to do it, right? And I lean more towards the latter of it. You're adding overhead too, right?
Yeah.
In general, for the API server, you got to definitely consider it. Everything else should be encrypted, as kind of what we were saying here. It's like it's all TLS, it's all RBAC. So you're not going to play man in the middle, unless of course you deployed etcd without TLS.
Yeah,
you could, but
yeah, that's a great idea.
Yeah, just saying it could be done. It's somebody says it's easier. Let's do it.
Actually, no, can it be done?
I'm not even sure in etcd anymore. No, not in Kubernetes. You can do etcd unencrypted.
Because a lot of them now, like a lot of it, it's really hard to actually not use. It's actually really hard not to. Well, I'm just gonna make sure my wife is calling me, so I'm making sure it's not an emergency. But I don't need these notifications. But yeah, so cool. So the last thing I'll kind of bring up here before we dive into the labs. So we decided to use Vault for our labs in this chapter, and we're going to use it again next chapter when we start talking about vCluster. And at the time, it was a little bit of a choice that we had to think through, because while we were writing the book, HashiCorp changed its licensing from Mozilla Public License to Business Source License. Now, I am not passing any judgments, right? I'm not getting into whether or not I agreed with the move. I appreciate the move. I think the move was I'm not getting into that. We decided to stick with it because it's hard to argue with the fact that it's probably the most popular out there in the enterprise. Like if you're not talking about a specific cloud, CyberArk has the Conjure open source one, which never really seemed to get much traction. Like never really seemed to, and I don't really know why. I've got no opinion on it. I will say shout out my old friends at PwC wrote a paper about it. But other than that, like I never run into it out in the wild. I've never run into it. It says, yeah, I use CyberArk Conjure in production. And then you got VMware has they don't call it Tanzu anymore, right?
They still have Tanzu for certain things.
Okay, I'm not sure.
They are trying to get rid of the name.
Yeah,
but
they've got their own secrets manager. I think that's a new open source one too. Like it's small. It's supposed to be lightweight, under very heavy active development. But we decided to stick with Vault because as even though Vault's open sourciness is up for debate, like the business source license is not a OSI approved license. It's an OSI approved license. For the folks who are going to be running this lab, assuming that you don't take the lab and turn it around into a Vault as a service offering, you'll be fine. Now, since the book's been released, I think the IBM deal has gone through, hasn't it, for HashiCorp?
God, it was final. Yeah.
They, I think it went through. I don't think they've done anything about the licensing, and I don't think they've announced anything about the licensing. So, no new information there. But let's go ahead and start the lab. So I am on. If you've got your book open and you want to follow the bouncing ball, I'm on page 251. And I was having some issues before. I don't know if it's because KubeCon and everybody's running demos, but I was having some serious issues with setting up clusters earlier. So I'm going to go ahead. So I'm going to adjust my microphone so I can actually see. So kube control get nodes. We're good. Yep. Okay. So export. PS1 gets that. All right. So we're going to go into chapter 8, Vault. And we're going to go ahead and deploy Vault. So this script is going to deploy Vault for us. It deploys, first it deploys Cert Manager because Vault has a web UI. And you need to trust the certs in order for the helper components that we'll get into to work properly. Now, we're not going to dive too deeply into how to configure Vault. I mean, that's a whole, like there are literally a couple of books written about it. All we're going to do is we're launching it here, and we're going to go ahead and unseal it and make sure it all works. So at this point, what we've done is we've deployed the Vault manifest or Cert Manager. Now we're deploying the Vault manifest, and we're waiting for Vault to become available. And we have already, I think we're done, right? Let me double check here. Yeah, so this shows that we've unsealed Vault. So if we do kube control, or let's go ahead and clear kube control, get pods, and Vault. Yeah, okay, so Vault's running. So if we hadn't unsealed, you'd see this as a 0 out of 1 ready. So if you do run this, there is a script in there to re-unseal it, to be able to run unseal without having to redeploy everything.
Probably mark here to point out we're running this in cluster. Now,
right.
You often will see enterprises, of course, run this external to the clusters because you're probably going to use Vault for other things, right? You could be using it for, as you're saying, it does a ton. There's multiple classes and books on it. But there are, of course, reasons not to run it intra-cluster as well, right? You start losing one, you lose the other. It's kind of like monitoring your own cluster in the cluster.
Yeah.
There's just reasons not to do something like that. So in this case, it's a lot easier than trying to say, okay, let's get a VM. Let's try to offer it externally. It all functions the same when it's pretty much consuming. But
now along that point, oops, maybe I didn't do it. Is it vault.apps? Along that point, there we go. So along that point, the way we set up the lab is to simulate it running in an external location. So we're still running it in cluster, but the but we're going to access it through an ingress. So we're not going to access it directly through like a service. It's still going to go through ingress. So Vault's got a lot of different ways to authenticate. And because this is not a chapter about Vault, we're going to cheat and we're just going to go ahead and grab the token. So this unseal keys gets generated by that script. Now, the tricky thing is about Vault is it's very unforgiving. If you lose those keys, don't just start over. So I'm signed in. Now, one thing you'll notice is that Vault is a single page application. And if you do a refresh, you got to log in again. Now, this isn't true of the different authentication types, but when you're logged in with the root token, that's sort of one of the things that they make sure to point out. So we're logged in. We have our root token. And so then we get into how a pod authenticates to Vault. And so I'll go ahead and share this picture. So ideally what you want to do, because if you think about our chicken and egg problem here, what you don't want to happen is you don't want to have a static credential that you're using to access your secrets, because that would kind of defeat the purpose. So we talked about in chapter 6 how service accounts give every pod an identity. So this is an example where that identity really works to our benefit. We can say, okay, we're going to have our pod call the Vault API, and don't worry about how. We'll get back to that. Have the Vault call the Vault API with my pod's identity, right? That's short-lived, shortish lived, but it's also bound to my pod, right? So if somebody gets that token after my pod dies, it, whether it's still valid or not from a time perspective, it won't work anymore. So you send the pod over to Vault, or you send the service account token over to Vault. Vault does a token review request to make sure that the token is still valid. And as long as it's still valid, it lets you through. Now, this does bring about kind of a chicken and egg, because that means Vault needs to have a long-lived secret. It would be really nice if Vault knew how to provide an identity provider that Kubernetes could authenticate against. So kind of like we talked about with the CI/CD proxy use case, but unfortunately, even though I've opened that as an issue, never got implemented. So we're going to want to set that up. Where's my cursor? So let's see here. Where are we? So let's go into chapter 8. And just to show you, so today, right now, you only have one authentication method, right? OU token or auth token. So what we're going to do now is we're going to configure Vault to instead use or to also have support for Kubernetes authentication. So I'm on page 253 if you're running this at home. So where am I? I'm still in the Vault. Yep. So I'm going to run Vault integrate cluster. So what we're doing here is not a lot going on here. Let's take a quick look. So we create a namespace with a service account. We add the service account to a token review binding cluster role. So that's a special service account that gives you the ability just to validate service accounts, basically, right? That's it. And then went ahead and configured everything inside of Vault. So now if we come back into Vault, we'll see that we now have this Kubernetes authentication mechanism. So this is something that allows us to call the Vault API with the Kubernetes token, get a Vault token back, and start communicating. All right. So now that we have our Kubernetes and Vault integrated, I think we can actually start having some fun. So next we dive into, so using a hybrid of external secrets management and secret objects. Page 254. Okay, so this kind of talks about what we were getting at with if Kubernetes secrets are fine and you want to externalize your secrets, how do you do that? And the answer is synchronize secrets from Vault into Kubernetes, right? Let's keep it simple. And so there are a couple of different projects to do that. The first one we start working with is the Kubernetes secret store CSI driver. This is the first one I worked with, and I'll be honest, I don't like it. Not for this use case anyway. In order for this to work, it's a CSI driver, which means it's a storage driver. So in order to synchronize the secret into the API server, you first have to mount it, which is kind of counterproductive. So like I ended up having to build like a deployment using the Kubernetes pod container to mount it, which would then synchronize it. So this is extra step. I don't love it, but it works. So let's go into the lab.
As you're deploying that, Mark, I have to jump off.
Oh no, man!
Apologies. I got a little thing.
Day job?
Yeah, I got something on that side that there was a conflict and I didn't know the meeting was that important. So I got to go over to it.
Okay, man.
Appreciate everybody,
All right.
but you're in good hands, obviously.
We'll talk to you next week, my friend.
I'll see everybody.
Bye. All right, so I am on I'm on page 254, and we're going to go ahead and okay, we're actually going to focus on external secrets operator. So the external secrets operator is same concept as CSI secrets. The main difference being that the external secrets operator actually is just a synchronization engine. It's just pulling your Vault or whatever you're integrated with. It works with Vault and all the different clouds. I love it. I think it's great. And I think it does a great job of giving you that balance between externalizing and externalizing while still getting the benefit of a centralized secret manager. So I'm going to go ahead and let's deploy. Where am I? So I'm in chapter 8. And I'm going to go into external secrets. So this is going to deploy the external secret operator. I don't remember why Prometheus is in there, but like most systems, it's a CRD. Now, the nice thing about external secrets is that you can check an external secret into your Git, because the external secret CRD, which we'll look at, contains metadata about where the secret is stored, but doesn't contain the secret itself. So that really makes it a lot easier to check into Git, because if you lose that, you're losing metadata, which you don't really want to lose. But at the end of the day, you haven't compromised anything. So we have external secrets running. And let's see here. And we do create we did create a secret store. So if we do kube control get secret store Vault backend, in the namespace, my external secret. All right, so we can see that's talking. Let's take a real quick look at it. So we're going to tell the external secret operator where to get the service account, where to get the certificate, where Vault is, right? That's it. There's no secrets in this configuration. So if you lose this, you've lost some metadata. Somebody will get mad at you, but there's nothing here, right? So this is how external secret operator knows how to talk to our Vault. The next thing we have to do is actually define, keep losing my cursor. The next thing we have to do is actually define what the secret looks like and where to find it. So if we do get or kube control get external secret and my secret. All All right. So we have the secret there. And if we take a look at what we have, you can see here that we're referencing a secret store, right? We're looking at where the secret is. And I think we've already created this secret. So let me just take a look. So if we come here and we go to secret engines, secret, yep, data, external secret config, some password. So that's our super secret password. Make this a little bit bigger. It's a little easier to see. So we've set this inside of our vault, and we are now synchronizing this into our namespace. So like K get secret and my X secret. Right. So we're now actually right. So let's do jq-r.data. Oops. Oh, that's what. Okay, get secret. You only want one. And it's going to be called secret to be created. Right. And then let's go ahead and dot some password and base64-D. Right. My super secret password. My super secret password. So that's getting synced in. So now, so that's how we're able to get that passed in. And okay, so we did that part. So the next question is, how do we go ahead and integrate this data into our pods? And you have a few different ways you can go about it. The first is through a volume mount. And this is kind of what's always been taught. This is the right way to do it. I'll be honest, I don't love it. One reason, it bypasses RBAC, and I'd rather do things via RBAC. Second, it kind of puts you at the mercy of having to reload things. Whereas, I would rather just have that control myself. Now, it's preferred over the next option, which is environment variables, because in theory, the reason why you're told not to do things by environment variables is whenever there's a debug statement, usually the first thing somebody does is say, okay, print out all the environment variables to see what's going on. And so that becomes an issue because now you're printing out passwords and stuff. And I do know firsthand, I've had many a customer who said, okay, we're going to, we accidentally left the debug page that prints everything out in production. So that is a valid concern. And then if a pod is updated, okay, so a big difference to note between volume mounts and environment variables is that if the volume is updated, it's not immediate, but your pod will eventually get updated. If the environment variable is updated, it never changes. You have to restart the pod. And then finally, the secrets API. This is my favorite way to do it. Like when Open Unison reads in secrets, it generally does it via the API, because that way I can get the latest version of it. I don't have to worry about syncing in. It's a standard. It'll work on every Kubernetes cluster. And it'll honor RBAC. You could always talk directly to Vault in your application. I would highly recommend against it. Unless there's a really good reason to, I would not tie yourself to a single secret API. All right, so I think we have an example of doing this with first a volume. So let's see here. If I go into, where am I? Clear Pass. All right. So we're going to go into chapter 8 and we're going to go into integration and volumes. And we're going to look at cat volume secret.yaml. So this is real simple. Create a volume. We're mounting a secret. Okay, create f volume secret.yaml. All right, so that's been created. And let's go ahead and see what's going on. So we'll have something that's just printing it out, like no big deal. Right, there it is. So that's our super secret password. And then yeah, so that's our new super secret password. Pod, we can update the secret in Vault and see what happens. First, create the pod. All right, so I'm going to go ahead and delete this. So I am now on page 258. So created that. Now let's go ahead and watch it. All right, so we see the password that's in there. So we're going to go ahead and update our password. So we're going to set up our Vault API. And we're going to go ahead and set a new password. Oops. Right, so we've set a new password. And now see if the password synced in. So once the password has been changed in Vault, it needs to get synchronized by the external secret operator. So we can see here that it has not yet been synchronized. So let's give this a hot minute. Yep. Clear. Oh, there we go. See, it now says another password. So the external secret operator synchronized it into our secret. So now that secret is mounted into our pod. So let's see if is now, yep. And so you can see, let's see when it actually happened. So you can see here that it changed from my super secret password to another password. Now, how long that takes is not constant between API server implementations. It's not something you can really rely on super well, but it does work. So we did that. So now the next option we can take is sidecar injection. So instead of integrating directly with Kubernetes secrets, we can say, you know, we're not gonna keep anything in the API server. We're gonna go ahead and put it all in Vault, and we're just gonna create a mount inside of our pod that has the secret data in it, but we're not gonna do it via a Kubernetes secret. So this keeps the secret information from ever being stored in etcd. Is this that big of a deal? I personally don't think so. It doesn't save you anything from a compliance standpoint, because if data moves through a system, it's the same as being stored in the system. So any controls that are in place because data is stored are still in place if that data just moves through it. So forgetting secrets for a second, let's talk about passwords. Let's say you collect a password in order to authenticate a user. Even if your system doesn't store that password, it could, even accidentally. And so every compliance checkbox that you have to hit for passwords, even though you don't store it, you still have to go through. Same thing with secrets. Even though the secret doesn't get stored in your etcd database because it's part of your system boundary, you still have to have every compliance checkbox when it comes to secret data. So I just don't think it buys you anything. I don't like it. It adds a lot of overhead, but if you like it, you go for it. Vault uses what's called a sidecar, and I think we talked a little bit about this in the manifest chapter. A sidecar is a special container. It's not your main process. It's meant to help your main process. And so the injector has two components. It's got an admission controller that, you add a annotation to your pod, and that's what tells it to execute. And then it's got the actual sidecar that gets injected into your pod. So we're going to go ahead. I think, do I have this in a file? I'm pretty sure I do. I'll just double check here. And vars. Nope. Volumes. Thought I did this in a. Oh, there we go. Less volume vault watch. Here we go. So we put these annotations in here, and the annotations are what tell. First, it tells Kubernetes, hey, or it tells the admission controller, hey, this is where to find my secret information, right? The second part is it then tells the sidecar where the information is. So it's a and how the secret gets set up. So it's a two-part process. Can't speak. It's because it's after lunch. So we dive into what all this means in the book. The important thing here, though, is that we are going to connect to our vault from our sidecar using our generated secret, or our pods service account token. So there's no static secret here. So I'm going to go ahead and run create vault. Oops. So I'm on page 262 if you're following at home. So I'm going to run this create vault script, and really all this does is you might have seen there was an IP-ADDR in there. It just replaces that with the right IP address. So we ran kube control vault. So now let's take a look at the pod. And we can see that our pod is talking to vault. And let's take a look at the pod real quick. Kube control get pods and my X secret. And we'll see that our pod is running two containers. So we've got our HashiCorp sidecar, and we have our what's the other container? Just Ubuntu 2204 running a script. So that's all going. Now, one thing that's important to note is that if we change this in Vault, it will never get updated here. I think there might be a setting to do that. I'm not sure, but excuse me, most people don't do it. So that's another reason why I like external secret operator. So that's how we do things with volumes. Now let's kind of look at how you do secrets with environment variables. And so I created an example here called envars. So let's go ahead and go into envars. Now with envars, I did I create a vault watch? I guess I did. So I'm on page 263. So let's take a look at envars secrets. And there's not really a lot of there. We define an environment variable and we say we're going to get it from the secret, right? So kube control create f envars secrets.yaml. And page 264 says go ahead and run the logs. So let's do that. And there we go. So all of our environment variables, including my secret password. Now, obviously, you might have seen that this shows exactly the problem we were talking about, right? You don't want to be in a situation where a debug statement is going to leak your secret information. So then if we update the secret, nothing's going to happen. So we're going to do this. So I'm on page 264. So we're going to go ahead and create this envars watch pod. And we're going to watch it, right? So let's go take a look. And our password's going, right? So let's go ahead and update our password. Right? So we've updated the password. Now let's go ahead and see if it's updated. All right, and remember, this takes a hot minute. Clear. And, you know, if you're watching at home, please feel free to, you know, ask questions. You know, we do love answering them. So we're going to wait for a second for the secret. There we go. Okay, so the secret's been updated, right? Now, when we did this before with volume mounts and we switched over to watching the output, right? It got updated pretty quickly. It's not going to update here because it's never going to update, not until we delete the pod. So let's go ahead and delete the pod. Kube control delete pod. What was it called? Delete pods. L run gets watch env and my X secret. All right, so that's deleting our pod, and we're going to go ahead and recreate it. Wait for pod to actually go away. 1 Mississippi, 2 Mississippi. Like, I don't know if it's because it's KubeCon or what, but I'm going to tell you, my clusters have been running slow today. All right, so that's done. So we'll do kube control create f envars watch, And then let's go ahead and watch. So now we see it's got the new password. So we had to delete it to bring it back. All right. So finally, what about Vault and the Vault sidecar? So this is where things get kind of tricky because Vault doesn't actually support environment variables. So if you want to be able to do environment variables, you actually have to generate a sidecar and then go ahead and add everything to the environment from inside your pod. Which I did as an example, but it's not very pretty, and I don't think it's a great idea to go. But what do I know? So we're going to go to Envar's Vault Watch, and so our command is this is what we do is where we actually source everything, and that generates it into the environment variables. This is a very bad way to do things. It's not consistent. It gives you the worst of everything. Like if you absolutely positively had to do it this way, I guess you could, but I wouldn't. So yeah, so that I think concludes, we don't dive into the secrets API. We don't dive into the Vault API. We will look at a little bit in the next chapter when we get into V clusters, because we're going to integrate our Vault into a V cluster. Probably going to spend 2 weeks on that, maybe 3. There's just a lot of content there. So anyway, that concludes our Vault chapter. Thank you, everybody, for coming by. If you are enjoying the book, please, please, please review on Amazon. Would mean the world to us. And next week, virtual clusters. Same bad time, same bad channel. Thanks, everybody.